We have reached the 5th video in this series, and we haven't even started talking about Saudi Carnot. And the reason is we're still around 1800, 1790s, 1800 or so, and a guy named Napoleon came along and started what became known as the Napoleonic Wars. And this was extremely important for the development of the steam engine. Not because they had military applications, they were still a bit underpowered for that, but because most of the steam engines in the world were built in Great Britain. There were a few builders in the United States just trying to get started, but most of the steam engines in the world that were powering the factories in Britain and on the continent were built in Great Britain. When Napoleon went to war with just about every country in Europe, the supply of British steam engines was cut off. So the French scientists who had been experimenting with British steam engines couldn't get their hands on any more steam engines. Now, what are you going to do? The French scientists looked around and they said, well, maybe what we can do while we're waiting for these wars to be over and we get steam engines again is that we can calculate the theoretical maximum efficiency of a steam engine. That's a good project while we're waiting for the war to end. So they began postulating an infinitely long cylinder with a piston that could move and thinking about gases and pressures and temperatures and all that. And they came up with a number. They see it's pretty reasonable. This is the theoretical maximum thermal efficiency of a steam engine. Then the Napoleonic Wars came to an end. British steam engines were once again available on the continent, and the French scientists discovered to their chagrin that the typical British steam engine that was being exported at the end of the Napoleonic Wars was about 300 times more efficient than the theoretical maximum efficiency of a steam engine. Oops. Now, one of the reasons that the English engine builders had made this tremendous increase in efficiency is that they learned how to make high-pressure steam engines. The steam engines of James Watt were only a few pounds per square inch greater than atmospheric, but men like Richard Trevithick managed to create steam engines that were small enough and powerful enough to actually fit on a railroad. So they actually were able to invent the steam locomotive, and you needed fairly high efficiencies and fairly high pressures to make a steam locomotive actually run. If you're interested in the development of the high-pressure steam engine, there is a tremendously fantastic series of videos on YouTube hosted by Mark Williams. You may remember Mark Williams as the actor who played the father of Ron Weasley in the Harry Potter movies, but he also produced a series of videos on Britain's Industrial Revolution, and including one on Richard Trevithick and high-pressure engines. If you're interested in that, I strongly suggest that you watch it. Now, in addition to high-pressure engines, the British learned how to use steam expansively. Let's think back to our general chemistry. When gases expand, they drop in pressure, but they also drop in temperature. Pressure goes down, temperature goes down as gases expand. And we'll talk about how we're going to use that in a moment.